Hi everyone. Are you hearing me well? You can listen to me with no issue? Okay, fine. Hello, I'm very happy to be here in order to make this workshop with you. It will be about getting started with Hyperledger Fabric using Golang. We will use a lot of Golang today. So the objective is to answer this question, how to start writing a full-stack Golang application that interacts with a blockchain, in our case, Hyperledger Fabric. Before going deeper in the workshop, I will tell you that I can't cover everything. We are short on time this morning. I will not talk about Hyperledger Fabric, how it works in depth. I will give you some reminders in order to be together at the same level. I will not talk about how to generate and configure an Hyperledger Fabric network. But there is a lot of documentation. Also, you can use the first link. It's another tutorial made by our companies that provide instruction in order to solve this problem. Also, I will not talk about how to configure the Fabric SDK in Go. There is a lot of testing and comments in files on the link that can help you on this part. Take care. The application that we will build today don't follow all best practice for production use. So it's only for getting started and understand how it's work. I hope you have already worked with Golang because I will not give you a lot of help, but I can on this language. There is not a lot of instruction that you need to understand. I hope you will find a solution. If you have any issue, don't forget that you have an access to the internet for this point. So, who are we? ChainHero is a dedicated company to help other companies and governments to build and deploy public or permissioned blockchains. We have some references. We make formation. Also, we have built a lot of prototypes, and now we are working on production-ready applications. Okay, let's talk about a little bit about me. I'm an engineer from the Institut National des Sciences Appliquées from Lyon, in France. I attended at the École Polytechnique Fédérale de Lausanne, the EPFL, in Switzerland, here. I have some web experiences at Smile Open Source and Worldline at Natos company. And now I'm at the head of the research and development department at ChainHero for the last 2 years. So, what is the plan of today? So I will give you some instruction in order to start. There is 2 colleagues that can help you in order to solve your problem. Don't hesitate to to ask them if you have an issue. Then I will talk about what the application that we will build today looks like. And I will give you some reminders about Hyperledger Fabric. And then we will go deeper in the application, starting with the network, then the chain code, and finally the application that the end user will use. So, how to start? I hope that you have read some instruction before coming here, because you need to use a virtual machine that contain every package and every component you need to use in order to make this workshop. If you use a Linux environment, you can try to use your machine. I made this workshop on Ubuntu, and the package required are Docker Compose, the Golang, and the Golang needs to be well configured with your Go path and everything. The depth, the Go dependency management tool need to be installed, and the make command also is required. So if you have no time and you have not the right machine, the right OS, you need to use. I encourage you to use the virtual machine I provide in the link. We also have USB stick that are provided to you in order to copy the virtual machine directly because it's a large machine. There is all Docker containers inside, so if you download the virtual machine using the link provided, it can take a while. So use the USB stick if you can. So, what are we going to build? We will build a collaborative resource management system that allow people to add resources, it can be anything, and other people's and allow other people's to take the resource and use it. So why using a blockchain for this kind of system? The management of resource using the blockchain can allow a better traceability. You can look every person that used the resource in the time. Also, if you can, we can make this workshop a little bit specific. If the resource is a vehicle in a company, in a corporation, there is a lot of vehicles and a lot of employees use it. So, in order to facilitate the shared vehicle, you can use this kind of system in order to automate vehicle availability, and administrators can see at every moment who used the vehicle. So what about the data structure we will use? There is an admin, one or more. It's a person who proposes and manages resources for consumers. He got a name. When you go inside the code, you can add more attributes if you want. The consumer is a person who can acquire and then release a resource. He also got a name. And finally, the resource. It can be an object, a tool, a good, or services, which is manageable and consumable. So the resource got a lot of attributes, an ID, a description that provides more information about the resource, and a boolean that tells if the resource is available or not. If the resource is not available, there is a mission provided on which mission the resource is deployed. Also, the consumer that uses the resource is provided. What about the architecture? So, everything is manageable through a web interface. The server is stateless, which allows to be decentralized. So the server handles requests from admin or consumer users, and provide the authentication and invoke and propose on the Hyperledger Fabric network using the Fabric SDK Go. So, using this kind of architecture allows us to deploy this web server everywhere, and all information are stored in the Hyperledger Fabric network. There is two kinds of application. There is the chain code. You will learn a lot about the chain code the last days. So the chain code will be written in Go, and the web server will be also written in Go. So this will allow us to use the same data structure in the two applications and share a code. This allows to reduce the development, the time we spend on the development of the two applications. So let's see this movie that show you what can the admin can do. So first, he log in. Like you see, he gets a quick overview of the resources. In the resource page, there is all details about the resource. He can add a new resource. He gives an identifiers and a description in order for consumer to see information about the resource when they want to use it. So our resources are here. You can see details of the resource, who take the resource in the past, when the resource was available or not, with the date, and the transaction ID. Okay, the admin user also can delete a resource, and that's it. It's really an easy application. What about the consumer? The consumer also log in the application and get a quick overview of resources, but the consumer can't see resource not available. He only gets a view on resource he got and resource available. So he can take a new resource and give for which mission he will use the resource. And he can release a resource, and that's it. The consumer part is really easy. So that's it. So we will focus on a scenario for today. The first step is to create a resource. So an admin creates a resource and makes it available to consumers. Also, the second step is a consumer that acquires an available resource and informs for which missions. And finally, a consumer releases a resource which then becomes available. So let's sum up in this movie. On the left side, there is the admin user, and on the right side, there is two consumers. On the top, the consumer 1, and on the bottom, the consumer 2. So they log in first. I log in every account. So they all get a sum up of resources. If you look at for consumer, the sum up is different because they don't get all resources. So the first step is an admin user that creates the resource. So when we will use the application, you can make what you want for the description. You can use vehicles, for example. So the resource is created. You can see that every consumer see the resource. One consumer take the resource. He give a mission. And like you see, the resource is taken, and the second consumer can't see the resource anymore. Okay. Finally, the last step, it's about the consumer 1 that will release the resource, and that's it. Okay. So let's keep in mind this scenario. You will use how you can use what we saw in order to implement your solution. So let's talk about Hyperledger Fabric. I will give you some reminders. So I hope you already saw some kind of information about Hyperledger Fabric. What about the architecture? There is an application, is the part we will build today. There is a membership that allows people to get certificates in order to propose or invoke on the Hyperledger Fabric network. So the first step is the application that enroll. So he log in, he gets certificates from the membership services, and then he can propose some transaction in the network. So the second component is the peer. The peer is here and contain every information. The ledger is on the peers, so you can provide a lot of peers. Every peer have some roles that allow in order that can tell if the peer contains the chain code or if the peer contains the ledger. You can choose what the peers will be used for. Then, when the transaction is endorsed by the peer, it will be the application can build a transaction and will send this transaction to the orderers. The orderers are here for creating blocks. Orderer create blocks with a lot of transaction, and then the block is sent to every peers concerned by the transaction, by the block. So let's go deeper in the transaction process. So we are in a situation where the client A want to make a transaction in the network. He already got certificates from the membership services, and he will ask to his application. The application use an SDK or not, but the application will manage every underlying of the network. So the client A will ask to the network to make this transaction. Let's say I will invoke this function on the chain code. So The SDK will see what are policies inside the channel, inside the network, and will propose the transaction to every peers that are required in order to validate the transaction. So every peer will be they will receive the proposal, and each peers will endorse the proposal. So they will run the transaction on their chain code, on their own chain code, and they will store every data read and every data write, but they will not apply the change directly on the ledger. They only make a response with every information that is required in order to proceed this transaction, every information that is read and every information that need to be written. They had their signatures on the response, and they will send the response to the application. The application will look at for every the application look at for any issue in the signatures, and also the application check if the data read and the data written are the same for every peers contacted, every peers that responds. If there is any issue, the application can send another request to another peers, for example, in order to solve this problem. So this task can be long because we are on a network very asynchronized. So some peers can give some information very different from other peers. Finally, the application can build the transaction that contain every signatures of every peers and also the data read and write, and send the transaction to the ordering services. The ordering services don't check the transaction. They are only here to receive transaction and ordering them for making a new block. So they build a new block for each channel that contains transaction, and then broadcast the transaction to every peers on the channel. So every peers will receive the block, the new block, and they will use every transaction. They are ordered. So they take the peers takes the first transaction and apply the transaction on the chain code. Check if the data read don't change during this process, and if all is okay, the data are stored this time on the ledger. So a block can contain some transaction validate and some transaction not invalid. So this is the transaction flow. I hope you understand it's the basic in Hyperledger Fabric. So to make a summary, a recap, the application is the A on the left. There is a channel. It's the circle with the in, and inside there is one peer with a chain code and a ledger. Also there is an orderer in green. So the application connects to the peers in order to ask to the peer to endorse a transaction. He invokes a chain code. The peers use his chain code to read, to run the transaction, to run the function called, and the peers store data read and write. Then the peers send a response to the application, and the application checks if everything is okay and sends the transaction to the orderers, one or more orderers. They orders the transaction and build a new block. The block is then sent to the peers. The peers check every transaction and then add the change. So run again the transaction in the chain code and add the data write and the data written in the ledger. Okay. So, how to launch your first network? I hope you have the time to download the virtual machine. So take your time to check if the virtual machine works. So what about the network? For the application, I provided the scenario we saw. In a real context, in a real production application, maybe it's a proposal. It really depends on the company that will use the application, the context of the application. So it's a proposal for a situation where there is one company, and the company will use this application in order to share these vehicles. So the company only use one membership services in order to manage certificates for admin user and consumers. There is some peers. We can say that there is one peer for each actors, for each admin or consumers. Also, there is 4 orderers in order to make them to add some resiliency inside the system. So they will use the cluster mode. The cluster mode we can use Kafka, for example. Also, there is one channel because every information is stored inside one channel. So for the development, we only use one or 2 peers. We don't need to check the resiliency or to check if in a real context we only focus on the development. So in the virtual machine and the application I will provide, there is only 2 peers, 1 orderers, and we still need 1 MSP and 1 channel. So get ready to start. I hope you run the virtual machine and it's okay. If you go inside this folder, the repository is already checked out, already cloned. So for others, people that want to use their own Linux environment, check that everything is okay, Golang, Docker Compose, the make, the dep. and create these folders on the top. Go inside, check out this repository, and check out the first step branch, the step 1. So if you have any issue, there is people that can help you. I hope it's okay for everybody. So, let's take some time in order to be all at the same stage. So after that, oh yeah, all slides, these slides are provided on the agenda, on the scheduled events. So download the slides in order to get the scenario and every information, the link, for example. So you go on the schedule, the getting started workshop. At the bottom there is the link to download the slides. So the first step when you make this, take care for people that use the Linux environment on your machine. Take care of the uppercase on ChainHero in the path, because it will not work if you miss this point. Okay, so the first step is then to run this command. You go inside the folder and you run make, only that. This will make a lot of stuff. The first thing is a cleanup in the environment. If you already start this command before, this will clean up everything and then run the Docker containers using Docker Compose. Then the application is built and started. The application will first create the channel for the network in order that peers and the component communicate. Then the application will install and instantiate the chain code. Finally, the application will register 3 users, the admin 1, consumer 1, and consumer 2. And finally, the web server is started. So, if you have any issue there, we can help you.
There are some keys for taking the full image to run the depot. We got a VirtualBox image or VMware image. So you have a Linux with all the codes and every Docker image also inside. So there are a few keys, either red and black keys, like this one. So if you want to copy the image, no.
To recap, I will give you the first slide about how to get started. You need this virtual machine. There is USB stick for people that want to use the virtual machine. For other people, you need Docker, Docker Compose, Golang, and dep, and the make command. Also, in the virtual machine, the user is provided and the password is Fabric. So just run make and all is started. If there is any issue, there is an error that will appear in the log. So if you use the virtual machine, we test it a lot, and there is no issue with the package. So okay. So I hope everyone are on the same stage. So you need, like I said before, the make command make a lot of stuff. Everything is written here. So how to know if everything is okay? So before that, I will explain what the projects look like. So there is some folders. If you look at folders provided, there is the make file that contain every instruction, every task for running the network, deploy the application, everything is inside. Then there is 3 folders. The app folders is the application that run the web server. The chain code is the one that is deployed on the network. The fixtures folders contain every information about the network, every certificate, the Docker compose is inside. So let's go inside. There is an artifacts folder. The artifact folder, we will see after. Let's talk about the Docker compose YAML. It's the file that contains every instruction for containers in order to run the network. Every containers are listed inside. Every configuration for containers come from the env file, the .env, and other configuration are in the env folders. Also, the crypto-config contain all credentials, all certificates. For the network, the artifact folder contains the files for the Genesis block. What is the Genesis block? Is the file required for the orderers in order to make all synchronized for ordering. So every orderers needs this file to start. It contains a lot of configuration. If you can read inside, it's a binary file, but a lot of information are visible. We can see, for example, so fixture, artifact. Like you see, there is some text inside, some certificates and configuration. So is the configuration for orderers. Then there is a folder that's named My Channel that contains every information for creating the channel. There is the channel.tx. It's the file like it's a binary file, like the Genesis block, and it's also some configuration. The policy of the channel is provided inside, so you can also display the file. And there is some information, some configuration inside. So this file is used to create the channel. The last file is is here in order for application or other peers to know how to contact the network, how to make, how to go inside the network, how to proceed the communication. So the file contains some peers addresses. These peers are here in order to tell, oh, you are new, let's look at of the network I know already. So this file is just here in order to make new peers joining the channel. So how to get the crypto config and the artifacts folders? Like I said before, I will not show you how to generate these files, but you can use a link provided at the beginning in order to make this. So Fabric provides binaries to generate the Genesis block for orderers and the channel. There is binary, you provide a configuration file, and you use these binaries in order to build the Genesis block and build information for the channel. For development, also there is Fabric provides also a binary that generates all certificates for all components and user. So for development, you can use this binary. You provide also a configuration file that contain how many users you need in your application, or how many peers there is in the network, and the binary will generate every certificate for your app. It's not ready for production. Every certificates are self-signed, so you can't use for production. It's not ready for it. Okay. How do we know if everything is okay? So I hope you run the make command you saw before. You can look at for Docker Compose. You can look at for containers that are running on your machine. To do that, you need to use one of the two commands I provide. For the Docker Compose command, you need to go inside the fixture folder, because the Docker Compose use the Docker Compose YAML, the configuration file, in order to run. If you want, you can use the second command, only Docker, that will show you every containers running or not. So, if there is some containers not running, there is an issue. If the binary for example, the containers for the peer 1, if it's not running, the binary has crashed. The binary crashed if there is an issue in the communication in the network, or for example, if the configuration is not okay, if the peer don't retrieve his certificates. So if there is a container down, you have an issue. To get more information about the issue, you need to look at for log. To get logs about containers, you can use these commands. So the first one, the docker compose command, needs the docker compose YAML file also, not the other command. So if you look for logs, there is a lot of instruction. Because every configuration are on debug mode level of log. So every binary will give you a lot of information about what happened. Every log are set at a level. So, for example, if there is an issue, the log will appear in red because it's in yellow. So, if the binary crash, look at for red instruction in this text. Okay. So, have you any question about this part?
Can you show the main command?
Yeah.
Because it's like hidden by the video in the PDF that I have.
This command?
Yeah. It's in the directory. Which directory do I have to run it? The manager, resource manager directory?
You need to go in the resource manager, go inside these folders and just run make. It will launch everything.
Okay, it said that something couldn't be started because of certificate failed.
Are you using the virtual machine? Yeah?
But I'm retrying.
Okay. Maybe for this kind of errors, there is take care of the path. The H in ChainHero need to be in uppercase. Check that, because if it's not the case, certificate can't be loaded. Any other issue?
What needs to be in uppercase?
In ChainHero,
Yeah.
the H, the...
Oh yeah.
Yeah, okay. Okay. So, for people that don't want to write some code, all code that you need to write will be for the second part. So there is a break in 30 minutes. So I will just give instruction on how to write your chain code and how the application is built. The exercises are for the second part. So how to write your first chain code? You need to follow this interface for the chain code. There is two functions. The init function is called only once. When you deploy the chain code on the network, you first install the chain code on every peers, and then you ask to the network to instantiate the chain code. So you tell to the network that every peers need to use this new chain code you provided. So at this time, the init function is called. This function is here in order to make some initialization in your chain code, in your ledger. For example, if you need to init some data structure in your ledger, you will use this init function. The invoke function is then called every time there is a transaction, every time there is a proposal. So every logic will go in the invoke function. How you get information about the ledger, all is provided in the stub, the chain code stub interface. The chain code stub interface gives you some methods, some functions in order to get the context of the transaction and to access the ledger state. So the first function is to get what the user, the end user, asks to do in the chain code. So you get the arguments provided by the user in order to know what we need to do in the chain code. The get transaction ID provide a unique ID for the transaction. It's really useful in order to make some new keys. You can't use, for example, generate function in the chain code. Why? Because the network is decentralized. Every peers will run the chain code in a different manner. So if you generate an ID, for example, in each transaction, in each chain code, every result will be different. So the application won't be able to make the transaction. So don't forget to use the transaction ID if you want to get some new key, for example. The three other methods are here in order to manage the ledger. So get information inside the ledger, put information in the ledger, or delete a key value. Every information is stored in the key value manner. So you need to provide a key, and you will get the value that corresponds to the key. So other methods useful are get query result. You can use by default when you run the chain code in your network. The peers will use a level DB database in order to store the current state of the ledger. So the get query result is here in order to allow you to run a rich query. The rich query are useful if you use CouchDB. For example, in the peer, in the network, you can disable level-DB and use CouchDB. CouchDB can couch. For example, CouchDB is here, can provide some rich information. You can make a query by searching on the value and not the key, for example. So get query result is here in order to proceed this kind of transaction, this kind of query. If you don't use CouchDB, this will fail. So take care of the network structure. In the project we will run today, the CouchDB is already provided and ready to use. So you can use this function if you want. The get history for key is used in the scenario in the application you saw, is used, for example, to get every details of the resource in the past, when the resource was available or not. This is the function used for this kind of task. You also can get information about the user that sent the transaction, so you can get the creator of the transaction. Also, you can get the timestamp of the transaction. there is a lot of more function. For example, in the last version of Hyperledger Fabric, you have some method in order to store private information. You can use the ledger in order to put some private information. So information are is encrypted. And every creator or people that have the keys to decrypt the value can read inside. How to get information about the identity, or how you get identity information of the user that sent the request. Fabric provides a library, CID, that helps us in order to get information about the user. You can get, for example, the ID, the certificate, unique identifier of the certificate. You can get information provided in the certificate, for example, some attributes you put in the certificate, and this is really useful in order to check if the user have the right to read or write these kind of things. Okay. What is provided? So in the step 1 branch for the chain code folder, there is 2 files, the Go package, lock and toml. They are here for download libraries in the vendor folders. So these files are here, for example, to retrieve the Hyperledger Fabric library for the chain code. You can use other library in your code, and all will be packaged and sent to every peers that will install the chain code. Then there is some Go file. The main is the entry point. Then there is a util.go files that contain some helping function. For example, there is the get from ledger. Like you saw, every information stored in the ledger are bytes. It's not really useful when you want to store data structure, for example. So I provide to you this free function that make our life easier. For example, the first one is the function that retrieves an object in the ledger. So you provide the objective you want to retrieve. For example, in our case, this will be a user, admin, or consumer, or a resource. Then you provide the ID of the object. For example, for a resource, this will be the ID of the resource. And finally, all the results will be stored in the results you provide in the parameters. So the function will give you the structure filled with every information retrieved from the ledger. The update in ledger is here in order to update data structure in the ledger, and delete from ledger is here in order to remove key value in the ledger. There is no magic. The get from ledger use underlying function I show you. So the get state, for example, for get from ledger, you can look inside the file on your machine. All is written, so if you have any question on the code, I can help you. So what about other files? There is a model folders. It's a package, another package, and every information, every data structures will be stored in these folders. So why? Because the application that is stored in the hub folder at the root of the project will use this model package in order to reuse the same data structure that are used in the chain code. So every information in the model package is used by both applications, the chain code and the application. I put this information in another package to allow that. You can depend on the main package. If you have already written in Go, you know this kind of stuff. So what are provided in the model file? There is all data structure. So like I said before, the admin user, the consumer, and the resource. The resource look at that. So there is an ID, a description, and other attributes. And every attributes are stored in the ledger in bytes, but in the JSON way. Why? Because using CouchDB, if you store in the ledger JSON structure, you can then query information. You can run a query that will look at for value in the structure. To do that, you need to store JSON structure. Let's continue. So what happened in the main file? In the main file, there is the init function and the invoke function. The init function do nothing. There is nothing to initialize in our application. So let's talk about the invoke function. The invoke function, so the first step is to retrieve arguments, retrieve parameters provided when the user of the application invoke the chain code. So we retrieve parameters and look at if arguments are provided. Arguments allow us in order to know if it's a query is a read request or an update. Updates are write request. So we use the first argument in order to know that. And why using this separation? Because when you write the application, it's really useful to know if the request is for read or is for a write. Because the process is really different. When you want to read, you only need to communicate with some peers, and peers will give you the answer. There is no, like we saw before, in the full transaction process, if you want to write information in the ledger, you need to create a new block. So to do so, you need to communicate with the ordering services in order to tell to everybody in the network that there is a new information written. So when it's only for read, you don't need to do all this stuff. You only need to communicate with some peers and get the information. So we make this separation, this separation on query and update for this kind of task for the application. What about what looks like a query in the chain code? So when I want to query the admin information, I'm an admin user and I want to retrieve my information, for example, my name, that are stored in the chain code, in the ledger, sorry. So the query function is called, and then we look at for the second argument, the argument that tell which function I want to query, like you see, we check if it's an admin argument, and then we call the function admin. In the admin function, we first check if the user that made the request is an admin. So to do so, we use the CID library provided by Fabric in order to check in the certificate of the user if it's an admin user. To do so, we check the argument that tell if it's an admin or not, and if it's not the case, we send an error to the application. If it's not the case, to get the ID of the admin user, we also use this library to get a unique ID of certificate, and this ID is used to store and retrieve information about the admin user. So then we use the get from ledger. So you got an example of how to use this function. You first give the kind of object we want to retrieve. So in this case is the admin type, object type. Then we provide the admin ID. And finally, the data structures that will receive every information stored in the ledger. So we fill in the admin structure directly with the function. Finally, we can send a result to the application. To do so, we need to send some kind of bytes. So we change the object, the admin object, in bytes. And then we tell to the chain code that everything is okay with the chime success. And we give the bytes result. What about the registration? So an update request is the same things of the query is the same. So we check the argument to know what function we need to call. Then in the function we check if what kind of actor is want to be registered in the chain code in the ledger. So we get the actor type provided in the certificate. Then we get the ID of the certificate, and we store in the ledger the admin information or the consumer information. You can look at for code directly on the file. What about how you run your chain code? You wrote a lot of code and you want to test it. Fabric provides a mock interface to perform unit tests on your chain code. However, this remains very limited. For example, there is no identity management, so the library CID is not working with a mock interface. And also there is no consistency in transactions. So in a lot of cases is not really useful. You can test all your code, so you need to deploy the chain code and then perform some testing via an SDK or the CLI commands. So I hope that you understand that it's not really easy to write a chain code. It can take a while if you want to test, for example, high identity management, for example, is not really easy because you can't use the mock interface. So that's it. At ChainHero, we use an automated deployment that run the chain code on a simple network and then run some tests using an SDK. So in this kind of way of coding, we know at every moment that the chain code we will deploy is okay. So how to build now your first application? So what are provided in the step 1 branch? There is some files in the app folders. We retrieve the Go package, lock and toml files that provide the vendor folders. Then there is the entry point, the main.go. And finally, there is a config.yaml that contains every information for the Go SDK to run. Every configuration about the network, how to communicate with the peer 1 or 2, are provided in the config.yaml. So, what happens in the main.go? So the first step is to retrieve some flag from the CLI in order to know if the application need to create the channel or to install the chain code. Then we prepare and initialize the Fabric SDK. We will run a new instance of the SDK. And if the user asks using flag on the CLI, we create the channel and instantiate the chain code. The chain code you provided in the chain code folders. Then we finally register some user, the admin 1 and the 2 consumer. Every information of the user are provided in the main.go. And finally, we run the web server. So where are the requests to the chain code? The requests are in the Fabric folders. In the Fabric folders, there is 3 files. The setup that handle the Fabric SDK initialization, and there is all query and update in the 2 separate files, query.go and update.go. So how a query looks like from the application side, we use the SDK using the channel clients to make a query. In the query, we provide the chain code ID. In our case, we use my channel, so the chain code ID is my channel, is ChainHero sorry. You can look at for this kind of information in the main.go. Also, we tell which function we need to query, so invoke. And finally, we provide some arguments. So the first argument of the query will be the query, because in the chain code, we look at for the first argument to know if it's a query or an update. And finally, we append every other argument provided in the query function. We also provide a kind of way for the SDK to know if there is an issue. For example, when your query appears, it don't answer. With a channel with retry, we can tell to the SDK to retry for 10 times, for example. So then we retrieve the results, and we store every information in the response object interface that the user provides to the query function. So what looks the query admin? So we saw how the function is written in the chain code. And what about the application side? So we just give the data structure of the admin. So like you see, the model admin use the model provided in the chain code, the model package. So we use exactly the same data structure in the chain code and in the application. We also give the second argument in the parameters of the query. So in our case is admin, and we provide the structures. And finally, we get the results, and we return the admin information. So what about an update? Is very the same things is like the query, but in this case, before we run query, we use the SDK and we call query. In this case, for an update, we call the execute. So the SDK know that it needs to make the ordering phase in addition to the read that he made before. So it's very the same. We call the invoke function. We provide the chain code ID, and we make for the first argument the update, so that in the chain code we know it's for updates. So then we also can retrieve information, but for the update is not really useful. And finally, what looks like an update, for example, for register a user, we give a register arguments, and we provide the username of the user we want to register in the chain code. So, have you any question about the chain code and the application interaction using the Go SDK? Okay.
Change the keyboard of the VM.
Oh, yeah.
We are going to try to show you how to change the keyboard.
There is a little.
The virtual machine you download contain the French keyboard layout. You need to change this. So it's like this computer. You need to click on the bottom left and type keyboard. So okay, settings. So you need to type settings. I will run like you the virtual machine. It will be easier. Okay, so you go on this, you click on this icon and you search for settings. You open the settings and then you go back to get all settings and you go
Region languages.
in regions and languages. You add a new input source.
So by default there are only English, there are not many languages, but you can add or manage. You will see there are perhaps 5 or 6 languages here. If you need something other than English or German or French, you need to go on the other, you need to escape from here and manage instead languages. You can add languages here. You can remind me later, no, not install, it doesn't work. And here you can add,
install and remove language, and you
choose what
you can look out for your language, and then you install the language.
Let's try with German, for example. Yeah.
Can you just run the main command?
Yeah.
After we change
Okay.
the keyboard, and then you will.
Dutch.
Okay. Then. Yeah.
The password is fabric.
I believe you got the A as a Q because it's a French keyboard.
Let's use the Q. It's on the Q. For fabric. The default keyword. It's FQ.
If you have difficulties to write settings here, you can go to all application and settings will be appeared, or you can go directly here and click on this icon. It will open the settings panel. Yeah.
Okay. Here you choose plus, and here you can add German or Dutch. Other.
Over. Dutch.
Dutch. Okay. Add. And then you have both languages, both keyboards, and on the top you see you can choose, you can swap between both keyboards.
So I'm in French keyboard and I can switch to Dutch like this.
Okay,
Okay.
Now you're ready to run make.
Yeah. So I go inside the folder, so GitHub, ChainHero, and then Resource Management Manager. I check out the step 1. If you use the virtual machine, is already the case, and then you run make. It will be the coffee break. So we can take some time if you want, if you have difficulty, if you have question to help you. And the other parts will you will code, you will write some code in order to understand how all works. Because I talk a lot and I pass a lot of time on on some kind of data structure, and if you want to remind, to understand everything, you need to write a little bit. So this will be the exercises part just after the coffee break.